The third, last but one, or the very important part of this chapter is the theorem. This theorem states that if P divides A square, then P also divides A. If P is a prime number. This is the theorem. We just understand this and leave because it's just coming as one of the properties that are used to prove a number to be irrational. That's it. So if P divides A square, that means P divides A. I'll just explain with one example. 2 divides 36. 2 divides 36. Right? That means the theorem states that if 2 divides 36, 2 also divides 6. That's it. It's very simple, and the proof is very not important because it's not in the examination point of view. If you want, you can just read the textbook. So the important part of this is to prove a number to be irrational. Let me take the number root 3. Prove that root 3 is irrational. That is the question. Prove root 3 is irrational. So how do you need to prove? We need to use in between somewhere that theorem. That is, if P divides A square, then P also divides A. So this one we are going to use the contradiction method. Let us assume root 3 is rational. Then it can be of A by B form. That is, root 3 is equal to A by B, where A and B are co-prime. What is the meaning of co-prime? The two composite numbers, maybe composite number or a prime number, I don't know. Generally composite numbers that are having their highest common factor to be 1 itself and not any other number. Such numbers are called to be co-prime. Right? The contradiction is based on this assumption itself. So I'll just cross multiply. So B goes that side, root 3B is equal to A, squaring on both sides. 3B square is equal to A square. I'll write it as ulta. Here I'll write it as A square is equal to 3B square. What did I get from this? That means that 3 divides A square. But from the previous theorem, just now we learned the theorem. It says that P divides A square. Here what is it? What do we conclude now? Then 3 also divides A. This is one statement. Yes, that means that 3 is a factor of A or something. That is the meaning of that. So let me mark this as equation A. So A can be written as sum 3C. Since 3 divides A. Right? Let me mark this as equation B. I'll equate both these. Right? If A and B, I'll equate. Equating A and B. Before equating, we just see that B should be squared, both the sides. Squaring. I'll just square this. That means that 3C whole square is equal to 3B square. 3C whole square is 9C square is equal to 3B square. 3 and 3 is going to be cancelled. Let me write it as B square is equal to 3C square. That implies that 3 divides B square. From the theorem just now we learned, we are just going to write it as 3 divides B also. Right? This is the first statement, this is the second statement. From statements from 1 and 2, we conclude that A and B have common factor 3. contradiction was due to wrong assumption. Because our assumption was that root 3 was rational. But there is a contradiction that's coming at the end of this that proves this to be irrational. Right? Based on this, we can prove some other things. So maybe I'll take one more example and just wind up here. Let me take 6 plus root 2. We should prove that 6 plus root 2 6 plus root 2 is irrational. Or in simple terms, it can be given as the sum of the rational and irrational. This is rational, this is irrational. Sum of those two is irrational. You can be asked to prove like that also. So I'm not going to use these theorem for this. I'm just going to have the thing that root 2 is irrational in the case. We already know that here, right? 6 plus root 2, here also 6 plus root 2. I'm not going to write the steps again. Let us assume that 6 plus root 2 is rational. Then it can be written in the a by b form. That is 6 plus root 2 is a by b. So now I'm not going to cross multiply in the case. So I'm going to take 6 to the right hand side. Root 2 is equal to a by b minus 6. Right, here coprime has no importance, so if I don't write also, it's not so irritating for me. So where a and b are integers, that is the thing I need to know here. Yeah, let me mark this as equation 1. Since a, b and 6 are rational, RHS, or the right hand side of this equation 1 is rational, but we know that the root 3 is irrational. That's it. Then you go through that. This contradiction was due to the wrong assumption, right? I'll just explain once more. First, we are going to assume, as in the previous one, let us assume that 6 plus root 2 is rational. Then it can be written in the form of a by b, right? So that is 6 plus root 2 is a by b, where a and b are integers. Integers are rational, that's okay. So now 6 I'm going to take it to the right hand side. So a, b and 6 are rational. So if I do any operation with the rational numbers, it is going to come to be rational number only. It cannot be irrational in the case. So the RHS of this equation becomes rational only. But if we if this right hand side was rational, left hand side also should be rational. But we know that root 2 is irrational. But then why has this contradiction come? This contradiction was due to the wrong assumption. That's it. Thank you.